discuss about the introduction to electrical engineering. So, electrical engineering is a branch which deals with the production of power, transmission of power, and distribution of power. So, here there is the necessity for everyone. So, nowadays, everyone is very much interested in utilizing the electronic goods. So the demand for electronic goods day by day increasing. And necessity also, necessity for the things like laptops, computers, and ACs. So this is indirectly leading to the consumption, more demand of electricity. But you are using so much of electricity, and it is needed for you to know some some small things about the electricity. So that thing we will do it now. And so everybody says current gone, power is gone. So actually current is something which moves. Current is something which moves. So here current means we are telling about the movement of the electrons. Or telling about the movement of the electrons. So this electrons will move, or we can say the movement of the charge. Okay, that is negative charge. Electrons carries the negative charge. So we all know that how the electricity is coming to your house. So there is production somewhere else, and you are in so much of distant places. How it is happening so away, so many miles away from your house, and how you are able to get it, and how you are able to use it. It's a big subject. So, but you should have some basic knowledge about this production. So, there we are going to produce the generating stations by different modes, conventional sources, non-conventional sources, and renewable sources, non-renewable sources. So, there in the power station, by some mode, they are able to produce the power, and after they are able to produce, they are transmitting till your house where you are utilizing that power. So you are utilization is different. For industry, the demand is different, the load is different. For domestic, the load is different. For commercial, the load is different. For agriculture, the load is different. And for municipal purpose, the load is different. So the load is different and the demands are different, and the loads will be varying constantly. So these are all things. So you have some basic idea. Everybody will have some basic idea. You are getting current in your house. You are able to switch on the lights. You are able to use the TV. You are able to use the induction cooker. You are able to use the induction panel. You are having basic idea. So we are using the current. We are using the power. So everybody have basic idea. This is coming from somewhere else. So what the people think that just they on the tap, like water is coming, and just they will switch on, the power is coming. So that basic idea they have. So they know that from somewhere it is coming, and it is transmitted from through the wires. This basic idea everybody have. But in this transmission, what are the things which are included in this transmission? So you will have some basic idea. So we cannot transmit this electricity or current or power. Okay, we need by any medium. So if you want to transmit, we will take some materials. So that is conductors. So conductors are the things we are using in our wires. So what are these connecting materials? Okay. So anyway, graphite, human. So if you go in contact with any power, you will get shock. You will be severely damaged, or sometimes you will die. That means you are a good conductor. So, but if you go to the metals, silver, copper, aluminum, all these are good metals. These are good conductors. So you will get doubt. So if you observe in your house, the wires sometimes, if you, for some repair purpose, if you open these wires, so around that wire you will be having the insulation, and after you cut that insulation, you can observe that there will be copper inside that wire. So that wires will be small. So you should get doubt. So why these wires, these small wires, we are using the copper? And if you come out of the house and you can watch the transmission lines, big transmission lines, they are made with the aluminum. You should get doubt why these are made with copper and these are made with the aluminum, even though both are the good conductors. So here the cost enters. So copper is more costly than aluminum. So in large scale, we are using the aluminum for the transmission purpose. So in our house, we are able to afford that cost. So which is limited cost. So we are using the copper wires. Okay, like that. So conductors. So which are able to conduct, which are able to allow the flow of electrons, which are able to allow the flow of current easily, very easily. So that means they are conductors. They are conducting. So if you go to semiconductor, that means they will not allow easily, or at the same time they will not stop. They will not stop the passage of these electrons. So that's why we are calling it as the semiconductors. Okay, insulators. So it will bluntly stop the passage of power. So what are the examples of semiconductors? Are silicon, germanium. These semiconductors. So with the conductors, on the conductors, the entire electricity is dependent on the conductors. So the transmission, distribution, and utilization of load after the power generation. Next, so whenever this power comes to our house or comes to our office, there, what are the things you are using? You are using the laptop, you are using the computer, you are using the TV. So these are the electronic goods. So these electronic goods are dependent on the semiconductors. We need so much of semiconductor materials to manufacture these electronic goods. So electricity is based on these conductors, and electronics is based on this semiconductors, and on this electronics only the software is based. The software industry is dependent on this electronics. So next, if you go to the insulators, so there are so many insulators which don't conduct, which opposes the conduction. That is plastic, wood, rubber, extra, everything. So many things. If you see, so why? So first thing, in my previous video also I have told you that. So the story of the electricity starts with the electron. We don't know when the electrons are created. We don't know what is actual creation. So electron is atom is very old. An electron, similarly electron and neutron, proton, which is in nucleus. So if you observe the structure of the atom, so you'll be having the structure will be like this, and we will be having a proton with positive charge and neutron with no charge. These two will be in the nucleus, and electron with negative charge and almost negligible mass, and it will be rotating around this nucleus. So if you will get doubt why some materials are behaving, like conductors, some materials are behaving like semiconductors, and some materials are behaving like insulators. So that the secret is in this outermost orbit of these atoms. So the materials which which allow the electricity, which conduct easily, will have less than 3 electrons in their outermost orbit. See, you can observe in this diagram. So this is the conductor. So this is the outermost orbit. You are having one electron or up to 3 electrons. So everybody simply says that this is a conductor, this is a semiconductor, and this is an insulator. But why? Why they are behaving like that? Means the secret lies in the atoms of those materials. So in the outermost orbit, a conductor will have 3 or less than 3 electrons. And if you go to the semiconductor, it will be having exactly 4 electrons in the outermost orbit. You see, observe here, 1, 2, 3, 4. So it is having only 4. So exactly 4 means it behaves as the material where its atom contains the 4 electrons in the outermost orbit, or which will have only 4 valence electrons, will behave like a semiconductor. And more than this 4, so we are having more electrons in the outermost, it behaves like a insulator. So it won't accept. It won't accept. So first we will see what are the force, electrical property of atomic particle, which establishes force when it is placed in an electromagnetic field. So what is that? Charge. What is the symbol of charge? Some force. That force may be attracting or repulsive force. So Q is the symbol of charge, and units are coulombs, and charge formula is I into T. Q is equal to I into T. So law of conservation, this is based on the law of conservation of charge. So the net charge will be always 0. The net charge will be always 0. So either they may repel or attract. So now what is the current? Current is just flow of electrons, or we can say as the rate of flow of electrons in a conductive or semiconductor material. So these two only can conduct. Either it should be a conductor or a semiconductor. Semiconductor means you'll be having more resistance than the conductive material. So it is measured by the number of electrons that flow at a point in a unit time. So now, with respect to charge, we can say that I is represented current. Current is represented by I. Either it may be small I or big I. So I is equal to Q by T. So that simply, Q is the charge and T is the time. So I is equal to Q by T means that is current is equal to charge by time. The same thing I can say as the rate of flow of electrons. Okay. So that's what we can say mathematically. So here again we are having two different things. So if the current does not change with the time but remains constant, so that means the magnitude of the current and the direction of the current. So if it does not change and it is stable, so then we'll say it as it is a direct current. So because it is not alternating, it's not varying, so we'll call it as the direct current. So the symbol of the current is I. So if the current is varying, so generally it will be in some form of wave. So magnitude and direction. So we'll say it as the AC current. So then what are the units? So from the morning we are utilizing this current. So what are the units of current? That is amperes. That is amperes. Now here is one problem you can see. So 5 coulombs of charge flows at a given point in wire in 2 seconds. Okay. How many amperes of current is flowing? That means he has given coulombs. What is the charge? He has given the time. Charge and time. So already we know what is the equation. I is equal to Q by T. So that is 5 by 2. That is 2.5 amperes. So he has given the charge. The charge is 5 coulombs. He told that here it is the 5 coulombs. And what is the time? Time is T seconds. So that is 5 by 2. We will get the 2.5 at the just a small block. So this diagram will give you the knowledge with the entertainment. So this will be like this. So the amperes want to move in the conductor. Okay, the ampere want to move in the conductor, and volt want to push that ampere, and that ohm will be trying to stop that ampere. So he will be constantly trying to move, and he will be constantly trying to stop. This is what exactly happens in the transmission in a conductor or semiconductor anyway. So this is just for your idea. So here you can observe here. So this is with respect to time, the current in y-axis and time in x-axis. You see here the current is stable, just like straight line. And if you observe here, it is varying. So at starting it is 0, and slowly it has increased, and slowly it is going down, and again it became 0, and again it is going to negative, and again there it went to its maximum, and again slowly it is decreasing, and again it came to 0. So what is the difference between these two diagrams? So this red line is straight here, this is varying here, which is representing the current. That means, so already we have discussed in previous slide. So this is varying, this current is varying, its magnitude is varying, its direction is varying. So we will call it as the AC current, and we will call it as the DC current. So if you people enter into the lab, so you'll be having some ammeter which will measure the current. You'll be having some voltmeter which will measure the voltage. So for example, so I have given you 2 ammeters. So 2 things I have given you, and generally we'll be having both the AC circuits lab and machines lab. So you need to differentiate this AC and DC ammeters. How we will differentiate? So there will be sine symbol, sinusoidal wave symbol in the AC ammeter or AC ammeter. There will be straight symbol, straight line in the DC ammeter. So this is the simple thing you can, with that, why they are showing the symbol means that sine wave and straight line. So the sine wave represents the AC current and straight line represents the DC current. So why? So both have the advantages. So AC power we can transmit to distant spaces. So it can be stepped up and stepped down. So transformers you are using, you can observe at the starting of a colony or starting of a industry. So you can observe transformers. So these transformers will only work for the AC current. But what is the disadvantage of this AC means that you cannot store this AC. Only we can store in DC. So that is the advantage of the DC. And you observe here. So these electrons represented by the negative charge. See here. So these electrons, if you are giving a supply, they will move in a particular direction. Actually, we'll assume that they will flow from positive to negative. That is our actual assumption. So some energy is needed to move these electrons because there will be some resistance. Okay. So that for that movement we will use some force, some potential we will use to move these electrons. So this we are calling it as voltage or a potential or electromotive force because that force is moving the electron. So we will call it as electromotive force. So now we will see one small problem. If 70 joules of energy, so this problem gives the relationship between this energy and charge. If 70 joules of energy is available for every 30 of charge, what is the voltage? Okay. So the energy, he has given the energy as 70 and charge is 30 coulombs. Okay. So what is the voltage? So previous slide we have seen what is the relation between the charge and the current. Here charge and the voltage. So for that formula is W by Q. So the energy is 70 and the charge is 30. So you will get 2.33. So units of the voltage is volts. So you will get that also. So that is so voltage. So which is the thing we are using to move electron from one point to another point. Here point A to point B. So that is we are calling it as VAB. So the same thing we can write as mathematically. VAB is equal to dW by dQ. So the units of energy will be in the joules. Okay. The voltage, units of the voltage is volts. Okay. So we can write 1 volt is equal to 1 joule per 1 coulomb or 1 Newton meter per coulomb. So this is about the voltage. Next we will see the power. So power we can write it as W by T. energy at the rate of time, rate of change of energy. So that is W by T. So otherwise, we do the same thing, we can write it as dW by dQ into dQ by dt. The same thing we can write. So, but W by Q, you will get the voltage, and Q by T. So just now we have seen in the problem. So here, this formula I is equal to Q by T, and V is equal to W by Q. So there. So that means W by Q we can write it as voltage, and Q by T we can write it as current. That means P is equal to V into I. So the power. Power is the product of voltage into current. We can express. Okay. So what are the units of the power? So watts is represented by W. So it is now here we will see a small problem. What is the power in watts? So power units is watts. The units of power is watts. If energy equal to 50 joules, so he has given the energy. Okay, and is used in 2.5 seconds. So that means he has given the time 2.5 seconds, and he has given W. So you know P is equal to W by T. Okay, so simple. The answer is energy is 50 by T. So that is 50 by 2.5. So W is 50, and time T is 2.5 seconds. So that you will get the 20, and the units of the power is watts. So we have seen power, we have seen voltage, and we have seen current. So this is actually what happens in a circuit. So the minimum thing. So you need some source for the movement of the electrons. You need some element, either it will absorb the energy. So here resistance, resistive load, inductive load, okay, or capacitive load. So basic things, either it may be a resistive load, it may be an inductive load, or it may be a capacitive load. So whenever the battery is connected, so there should be a connection between this the thing which absorbs the energy. Okay, that is called as the wire. That is the wire. And this is the thing. This is the basic circuit. Okay. So here you can observe here. So I have connected the lamp. This is one type of load. So battery. So it will move the electrons. It will be the source of current. Okay. So there should be a connection. For this connection, there should be some medium, connective medium. That connective medium is the wires again, you can see. So battery will give the EMF, and electrons will move through the medium, that is the conductor, and this is the thing which is actually absorbing this power. That is the light here. In this case, light. Okay. So why I need some electromotive force? It is because of this resistance. So these are the resistors actually which you will use in your resistor. They are wantedly made. So here you can observe. So in a circuit, the resistor is represented by the box like this. And normally we will use this triangular shape of wave for representing the resistance. So this is European style and this is US. So all over the world we are using the US style in our so resistance. So something, the current wants to enter into a material. and that material is resisting that. So resisting is its property. It is having in its uh, in itself. So it is its basic property. So every material will have some resistance. So if it is less, it is becoming a conductor. If it is moderate, it is becoming a semiconductor. And if it is high, it is becoming an insulator. Okay, so that is a property of the material or element. Okay, it will oppose the flow of current through it, flow of electrons through it. Okay, what are the units? That is ohms. So it will be represented by the symbol. The symbol. It will be like a hat, side view of a hat. Okay. So this first, the person George Simon Ohm, German scientist, he is the person who found first why some force is needed to move these electrons in a conductor. On his name, so he has also proposed Ohm's law. So on his name, the units for this resistance came as the ohm. So it is. So this is the triangular wave. We are representing this resistance in the circuit in the triangular wave symbol. So Ohm's law, what it is telling. So the current passing, okay, is proportional to the applied voltage. So that is nothing but the force. The more force you apply, the more passing of the current. The current will be more. So the voltage will be more, the current will be more. The voltage will be less, the current will be less. If the voltage is more, the current is also more. Regarding the resistance and temperature is constant. Resistance and temperature is constant. So that's what that George Simon Ohm has done an experiment, and first he found that there is some resistance. That's why we need some potential or voltage, and how there is a relationship between this current and so here if you know, so according to his law, Ohm's law, so the equation is V is equal to IR. So if you know one quantity, if you know two quantities, we can easily find the third quantity. So this is the basic formula we are going to use in basic electrical engineering. So that is V is equal to IR. So I can write the same formula as I is equal to V by R. So 1 by R. So resistance is opposition. So what will be the opposite to the 1 by R means reverse to the resistance. So that is conductance. So it is the property of the substance which allows. Resistance is the property of substance which will not allow. Conductance is the property of substance which will allow. So that's why 1 by R is the conductance. It is represented by G. And the units. So you are represented by Ohm, the symbol, just reverse for the conductance. And also you are telling that ohms which opposes, okay, ohm which opposes, and the units for that opposite thing, conductance is mho, because this is exactly opposite. This R and G are exactly opposite. So already we have seen P is equal to V into I. You can write, okay, which is WAT, that we can write it as Q by T into. So finally, so this according to this Ohm's law, so V is equal to IR. So then again I will substitute this P is equal to VA. Again I substitute it V is equal to IR. So IR into I. So that thing I can write as I square R. Or again I can write this as V square by R. Okay. So that's what. The current through the conductor has 2 points is directly proportional to the applied voltage. That's what the Ohm's law is telling. And provided the resistance and temperature should be constant. And R is called as the, so here, so what is telling V is proportional to I. So if V increases, okay, I also increases. If V increases, I also increases. That's what he wants to say. But in between there is resistance. Another thing is called resistance. So that we can write as V is equal to IR, and R is the proportionality constant. And temperature will be, temperature and resistance should not vary. So now a small problem we'll see with this Ohm's law. So V is equal to IR. So 10 ohms. So what is the resistance? R is equal to 10. And voltage is given 12 volts. Okay. How much current flows through? So already I told you, with the help of this Ohm's law, we can find, if you know two quantities, we can find easily the third quantity. So that's what he has given here. So he has given two quantities, that is voltage and resistance. And so V is equal to IR, the same thing. I want I know, so I is equal to V by R. So the voltage is 12 and the resistance is 10, 12 by 10. So we get at the 1.2 as the current, and the units of the currents are amperes. We already. And similarly, we will see another problem. A 100 ohm resistance is directly switched on across a 10 volts bar. That means resistance is 100 and voltage is 10. What is the current through the resistor? Again, he wants current. How much power? So we need to find the power also, and also how much energy is consumed. So energy loss or energy is consumed. So voltage, 10 volts. Resistance, 100 volts. So first he is asking about the current. Yes. So I is equal to V by R. So voltage is 10 and resistance 100. So 10 by 100, that is equal to 0.1 amperes. Next, what here? What we want to find? That is the power loss. Okay. So power loss is nothing but I square R. So we can write power is equal to I square. So you know I. So that is 0.1. And resistance 100. So 0.1 square, I square. 0.1 square into 100. So that is 1. The units are watts. Okay. And also he wants to find energy consumed for 5 seconds. So that means I square R into time. Into time we have to have. So that is I square 0.1 square into R 100 into 5 seconds. How many seconds? 5 seconds. So that will give energy, the units 5. The units of energy is joules. Okay, so this is the result of Ohm's law. If you know two quantities, we can find the third quantity. So that's the same thing here. So voltage V is equal to IR. So V I into N. So V volts into I, amperes, the units into R, ohms. Similarly, I is equal to V by R. I amps is equal to V volts divided by R ohms. Similarly, resistance R is equal to V by I. So R ohms is equal to V volts by I amperes. Okay, next we will see another problem. So a small light bulb is connected to a 6-volt battery. So voltage is 6 and draws 2 amperes of current. So is equal to current. This is voltage. What is the net resistance? So he has given already voltage and current. The third quantity is resistance. R is equal to V by I. So R is equal to V by I. V is 6, I is 2, 6 by 2. That is 3. Okay. So these are small examples for. And next thing, a motor running with an operating resistance of 3 ohms is connected to a voltage source. The current in the circuit is 1.5. What is the voltage? So he has given the R and he has given the current. So Ohm's law is equal to I. So 1.5 and 32, that is equal to 48 volts. And also another problem, determine the amount of current going to be a 50 ohm resistor with a voltage. So resistance is 50 and voltage is 120. So he wants to determine the amount of current. So I is equal to, he asked for current, I is equal to V by R. So voltage is 120 and resistance is 50. So that is equal to 2.4 amperes. We get lines of current are 2.4 amperes. So today now we have seen. So what is the basic things of the current? Why some material is acting as a conductor? Why another material is acting as a semiconductor? And what is the structure of the atom? So outermost orbit. So how many electrons will be the outermost orbit of the conductor, insulator, and semiconductor? So what is charge and what is the current, and how the resistance will oppose the movement of these electrons, and how the voltage will give the force for the movement of the electrons, and what is the difference between the AC and DC. So how? So it will be straight. It is constant. So the current will be constant in the DC. It will be varying. Magnitude and direction will vary in the AC. So AC can be transmitted to longer distances and can be stepped up and stepped down, but cannot be stored. But DC can be stored. And we have seen some small problems. And what is the voltage? What is the power? What is small network? What is the resistance? And what is Ohm's law? And small problems for finding the current, for finding the voltage, for finding the resistance. So we know two quantities, we can find the third quantity. That is the benefit of the Ohm's law. Thank you for listening. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.